Hello everyone, I'm Jason Mays, Web AI Lead at Google, for our teams that focus on the art of running machine learning models client-side in a web browser. Today, I've come to share a story about why you should start investigating agentic behaviors on device within the browser in JavaScript to gain extraordinary abilities for your existing web applications, while also enabling privacy and lower costs for your business as users' devices continue to get more capable. In 2024, the Web AI community progressed towards a smarter web that was more powerful than ever before. Like this prototype that enabled videos to literally watch themselves for you, extracting useful video frames in real time to grab moments that matter automatically, and could even work offline. But this, while smart, was not an agentic behavior. So what's an agent? At its essence, an agent is a system that can perform advanced tasks autonomously on behalf of the user by breaking them down into structured steps that it can then complete without user intervention. An agent can dynamically select and use exposed tools, potentially many times in a loop, allowing it to interact with the outside world, filling in any missing knowledge it may need, or perform an external action to then complete each sub-step beyond the constraints of a core language model that it may be using, that ultimately is driving the agent's internal thinking and logic. Let's dive into this tools concept a bit deeper. While large language models contain a vast amount of knowledge about the world, if you ask one what the weather is today in London, it would likely hallucinate an answer that might be wrong. Instead, you can expose a tool that fetches the current weather for a given city that the language model can then choose to call with the inputs it needs to get up-to-date information about the weather and then use that response in its own contextual history to perform the task correctly. Tools allow the language model to bridge the gap between itself and the outside world. An agent can potentially use many of them to interact with various external data and services, unlocking more powerful actions that could be used to help it solve the goals set. The example shown here illustrates potential tools you may expose for a holiday planning agent. Common types of tools include calling a function to perform some task, or taking an action via an extension to use an API, or fetching relevant contextual information from, say, a vector data store. Next, with regards to language models used, this could actually be one or more LLMs or even multimodal models to understand inputs beyond just text, that are all capable of following instruction-based reasoning. If multiple models are used, the orchestration layer may decide which one to delegate to for the current subtask being performed. Essentially, an agent can plan and define subtasks that it needs to complete to get a job done, choosing the appropriate tools to use in each step, whose output can be used as extra context in its memory to then reason what it needs to do in future steps in order to complete them without constant human intervention. Even cycling through a chain of steps it chose to perform, potentially multiple times, breaking the task down further to eventually complete the request. So, bringing this all together, an agentic system is typically comprised of one or more large language models, a memory implementation, and one or more tools it can choose to call. These key subparts are managed and coordinated by the agent runtime, or orchestration layer if you will, that governs how the agent takes in external inputs, how it should loop to perform internal reasoning, and even in assisting in calling the correct tools that the agent chooses to use, based on structured outputs from the language model itself. Or it can enable an ability to ask follow-up questions to the user as needed, and may define valid stopping points to present results back to the user at key steps. Now, complexity of the orchestration layer will vary depending on your implementation. So, how does this all tie into Web AI? Well, last year, I made a prediction that websites of the future may need to be AI agent compatible, such that you could talk to them naturally to perform any of the tasks that they support to get useful work done faster without needing to learn arbitrary user experiences on different websites. I also predicted that sites that don't make it easy for agents to work with them may struggle to compete in the agentic AI age, just like how we had to support mobile versions of our websites in the past to stay competitive when the smartphone was invented. Today, I'll demonstrate a Web AI prototype that puts these agentic concepts into action to show you a glimpse of a possible future of the internet itself, where websites are designed to work interchangeably with agents and humans alike. I'll be using Google's 2 billion parameter Gemma 2 model entirely locally in the browser, powered by our MediaPipe Web LLM library, to show you how you can upgrade your existing site with agentic workflows by reusing your existing code exposed as tools that the agent can then use in a low-friction manner. If all websites embrace these concepts, we could enable a smarter web for everyone. Everything you're about to see is captured in real time on a 5-generation-old NVIDIA 1070 GPU, so these things will likely only get faster with time too. In this demo, we're going to simulate a flight search page similar to Google Flights to illustrate how this agent could work. Let's go ahead and attempt to book a flight using the AI Agent microphone button exposed, but purposely not give enough information. Hey there, I'd like to go on a holiday with my friend.
Where are you departing from and when? Is that a one-way trip?
Notice how the agent has already figured out that 2 people are likely going on this trip in the JSON output on the left. However, it also realizes that in order to use the website search tool, it needs more data to call that, so it asked us some follow-up questions too. Let's respond with what it wanted, but also include more data than it actually asked for to show how it can adapt to anything the user throws at it. We'll be leaving from San Francisco, but can you pick a popular skiing destination in the French Alps for us to go to? We'll leave on the 5th of December and come back 1 week later.
What is your preferred destination in the French Alps?
I don't mind. You pick a town that's good for skiing in the region. So as you can see, even though I spoke quite a bit, it successfully extracted the date information, figured out what 1 week later actually means, and suggested the popular skiing destination of Chamonix, which is a great choice. As it knows that it now has enough information to perform a search, it goes ahead and calls my search tool with the data. Now, in this demo, just for fun, I even got the LLM to generate fictional results too, just to show you how much knowledge of the world this tiny 2 billion parameter model has, even though it's not been fine-tuned. So at no point in this demo did I send any data to the cloud, although in real life, a search would probably end up calling your cloud API to get the latest results from a real flights database. And as you can see, it generated some realistic flight options and even returned European airlines. Alright, so we got some results, but let's show how versatile this is. You know what? We had a change of plans and an extra friend is coming, and we decided to go to Tokyo instead. As this is a special trip, let's make those seats business class, baby, and change the dates to a better time in autumn. So here, I'm hoping it increments the passenger count to 3, sets seats to business, and destination should become Tokyo. And I'm hoping for some dates in the September to November time range. And sure enough, it seems to have worked. Now, as I said, everything here is running entirely locally on my laptop's GPU, meaning that you could talk to it all day long and there'll be no inference cost involved. The only cost here is the initial download of a language model based on its size and the CDN provider that you're using, which is a one-off and it's cached for future page loads. Speaking of caching, I've created a useful caching proxy library available on the link shown that you can use when fetching large generative AI models from a server in just a few lines of code. This library makes it easy to fetch large binary files and then shards them into smaller chunks to fit within the limits of client-side caching APIs, and reconstructs the binary blob as a data URL so you can pass it to any library of your choice at runtime as if it were fetching a remote URL. And this is how easy it is to interact with existing website functions that you've already written. As you've seen, this can lead to an experience that's much more natural for the user, versus having to learn a new user experience for every website they view. Not to mention, even a visually impaired person could use this interface too, using just their voice, making the website much more accessible. Pretty cool, right? So if you're wondering how this all comes together, the diagram shows the key data flow for what I've made in the web app that you just saw. The key thing to take note of is that the agent orchestration logic in yellow just attaches to your existing business logic shown in green, and you can choose what functions from your existing web app to expose to provide it with tools it can use to get jobs done. On the page load, the web app downloads the large language model I plan to use from cloud storage to power the agentic experience. In this case, I'm using Google's MediaPipe Web LLM library to load the Gemma 2 2 billion parameter model and run it entirely locally in the browser. Once loaded, I can register functions that already exist in the existing business application logic shown in green as a tool that the agent controller then knows how to use to call as needed to perform any of the tasks that the website supports. Let's dive into this part a little deeper. In my implementation, the agent is flexibly defined in the side panel on the right, as shown here, to make it easy to edit on the fly for experimentation at runtime. As you can see, I define a persona along with the functions I want to expose as tools, just by using regular JS.comments that I've already got in my production codebase and could likely be auto-generated to some degree in the future. The agent is then aware of their existence to use as it needs. Now, the core pieces are connected, the web app is ready to go. A user can use their microphone to talk to the configured agent in a natural way using a lightweight speech input layer that I wrote. The speech is transcribed and then routed to the agent controller logic shown in yellow, and then it uses the loaded LLM with the defined agent persona and the exposed tools that are available to use along with the current user input. The LLM is then able to generate a response in a defined structured JSON format that the agent orchestration logic can interpret and deal with, such as asking follow-up questions if needed or calling a tool until it has enough data to do what's asked of it, in this case, to book a flight. In my example, a text-to-speech engine is also used to speak to the user if follow-up questions are required. Now, in case you're wondering how I knew what JSON structure to use, I specified this in the agent's configuration, whereby I gave example JSON structured output that I would like it to adhere to so that my orchestration layer can route its request to the right tool as needed by a common known interface to expect at runtime. I can change all of this at any point to experiment with different personas or work with other APIs or functions that I've exposed if I wanted to, making it very easy to explore future options. Finally, when enough information is obtained to perform the desired task, the agent can call the search tool exposed by the business application to actually find possible flights that match and bring those results back. The results are rendered to the user interface via the existing logic in the web app itself that would already have been handling search results in the non-AI version of the site, so you're just reusing code that you've already got in production. Once the results are rendered, the user can make a new request, maybe to apply further filters or change destinations as they desire, kicking off the whole process all over again. Except this time, the agent has a memory of the prior conversation, so it doesn't have to ask so many follow-up questions. Okay, so with that in mind, I can now reuse the same logic with a different web application that has different exposed tools. In the example here, I made a Web AI DJ in just one day by reusing the framework that you just saw that works with public APIs for music services to show how versatile this can be. I even upgraded the text-to-speech engine to use a Web AI model known as Kokoro for a more natural-sounding voice. You can try it for yourself on the link shown. So, as you've seen, Web AI is the art of using machine learning models client-side in a web browser, running on your own device's processor, graphics card, or even NPU using JavaScript and surrounding web technologies like WebAssembly, WebGPU, or emerging standards like WebNN for acceleration. And in some cases, the base AI model may even be built into the browser itself and exposed to JavaScript developers via emerging APIs for common tasks like prompting, summarization, and translation. So do check out Chrome's talks at Google I/O this year to hear their updates. Now, all of this is different from Cloud AI, whereby in that case, the model would execute on the server side and be accessed via some sort of API instead, which means you'd need an active internet connection to talk to the Cloud API at all times to provide those advanced capabilities. Right now, generative AI in the browser is in its early stages, but as hardware continues to evolve with more RAM available to both CPU and GPU, we shall continue to see newer, more powerful models ported to run in browser on your device, enabling businesses to reimagine what you can actually do on a web page, especially for industry or task-specific situations. In fact, we could see smaller large language models in the 2 to 9 billion parameter range be LoRa-tuned for a specific purpose via the cloud and then run on consumer hardware to provide agentic behaviors like you saw today. And we're now at the start of a new era that can really enhance your existing web presence for the services and products you're already providing, and the time is now to start exploring how you could apply Web AI agents to your industry, augmenting the strengths of client-side Web AI and Cloud AI together. You could consider using hybrid approaches with these smaller local models today. For example, imagine you've got a vector database of domain-specific knowledge in the cloud. You could pair that as a tool with a Web AI agent on the client side to provide critical context to answer a user's request, allowing you to get a more advanced task done that otherwise the smaller model may not have known how to do. And by using both Web AI and Cloud AI together, it allows you to get the key benefits of both ecosystems. Now then, I'd just like to end by saying there are very few opportunities in one's life to be at the beginning of a new era like this. I, for one, remember when the internet came out for the first time. Yes, I am that old. And agentic Web AI has the same feels as that, only magnified 1000x. I personally believe that in the future, we will build AI-compatible websites like you saw today, whereby you've got the option to just talk to them naturally via text or voice, to perform any of the tasks that they support using an AI agent. What if every website had a publicly accessible file that's specifically written so that an agent can understand what tools your service can provide? That way, instead of the user having to manually figure out some arbitrary workflow or user experience, the agent can use that knowledge to get the job done in seconds. Now, the browser is one of the best places to do this, as you've already signed in to all the services you love and use daily, enabling you to use tools from all of those services in one place. I believe that sites that are not AI agent compatible may be out of fashion pretty fast, just like when we moved from desktop to mobile first, and we're now entering the age where AI agents are growing in popularity. So I hope in this talk, I've been able to provide you with a tiny glimpse into the future as to why you should start investigating Web AI today, because everyone watching here has a chance of a lifetime to shape the future of the industries that you work in for this fast-growing client-side space. And I hope all of you will join me on this adventure. So do tag me in anything you make at your company, or if you've got suggestions or questions around any of the technologies mentioned in this talk. You can connect with me on social media or learn more using the links on this slide. And of course, remember to use the WebAI hashtag if you make anything worth sharing so our community can find it. And with that, thank you, and I'll see you next time.